try to do my best. I also like to thank Dr. Eric Tisdale for allowing me to speak. Unfortunately, I have something that's going to require me to not be able to speak in my time slot. So thank you, Dr. Tisdale. Okay, so we're going to go over a couple of things here. There's only a few objectives that we want to reach over the next 30 minutes or so, but it's going to include some history. I think it's important from a conceptual basis to understand how we got to where we got. And so I did put that in, and of course, having gray hair, you know, I've lived through a lot of this history, so it's nice to talk about it on a first day basis. Electronic data collection, you know, are you kidding? It's funny because if you look at the European market, this is well established. Actually, even in the Australasian market and in Asia, electronic data capture, but it's been slow to penetrate the market here in the States, and we'll talk a little bit about that. And so now, great, you got data, but what are you going to do with it? You know, one of the probably least important uses of the electronic data capture system is to PDF a file at the end of the case and then insert it as such an attachment into any of the EHRs that are out there. We all do it, but there's really a lot better way that we can be handling it. So let's, since Jeff had selected this title, Ty told me to keep it. He wouldn't let me change it. I had no idea what it was Jeff was going to talk about because he named it The Good, the Bad, and the Ugly, so I put in a couple of bullets on each one of those. Joseph Lister in the 1880s, well known to all of us, he used principles of microbiology that were developed by Pasteur just a few years earlier and applied them to a surgical setting. And you know, you think that, oh my gosh, that was a great idea, everybody incorporated it and used it. That's not what happened. In fact, the surgeon groupings in Europe at the time were bombastic. I mean, these were individuals who knew everything about what they were doing, and they thought that what Lister is saying in regards to providing phenolic-type compounds to surgical sites was crazy. And so they didn't embrace it quickly. It was actually embraced more fast in the United States, even though they were across the ocean. But what he did was something unique. He was a very, if you read any of the articles about him, he was very soft-spoken, and he was really a statistician. He used data. He used the power of data to get the point across, and he didn't use threats and said bombastity. Perhaps more important, anybody know Danny Willett, who's teed off today, I think at 11:45? Well, Danny Willett did something that was quite unique, and this is a guy who had never played Augusta before winning the Masters in 2016. And he was the last one to show up for a practice round. Everybody else had been practicing, you know, the big names for days on end. He was the last guy to show up, but what happened was his caddy got an email from a statistical group in London that said, you know what, we went back and looked at 20 years of Masters. Everyone who won the Masters over those 20 years did something that you should be aware of. They laid up at the par fives. Is what they did. So he did that. That was his whole philosophy. I'm not saying that's the only reason he won, but you know, clearly using data was beneficial. But if you don't believe that, if you go back and look at the 2001-2002 Oakland Athletics, Billy Beane did something remarkable. He used quantitative analysis, which, you know, there were loads of data on baseball before that, but he actually applied it. And he said, you know what, on-base percentage and slugging percentage are better indicators, metrics, for how well I can attract individuals and get them here in the A's than if I use any other type of home run hitting or whatever. And in fact, at that particular time, 2001, 2002, I'm a New Yorker, so the Yankees' payroll was 127 million. His payroll was 44 million, and they went on, of course, and did very well over those years. The bad. These two publications are phenomenal. Everybody's seen them. I used to give them out as presents to my students upon graduation, and these have done more to change healthcare in the United States than anything that has ever occurred in the history of medicine. Lucien Leap, Don Berwick, some of the people who were writers on these particular monographs that were published by the Institute of Medicine used data from the 1980s. Anybody here doing cardiac surgery in the 80s? In the 80s? Okay, remember what happened with the Journal of Thoracic and Cardiovascular? It was like half of us, oh my gosh. Remember what happened? All the editorials, if you remember, if you go read back to 81, 82, 83, 85, they said, you know what, the release of cardiac surgical data and letting it become transparent so people can see what we're doing will kill cardiac surgery. It'll drive a nail through it. It's the worst thing that can possibly happen. Dwight Magoo, who is the editor of Journal of Thoracic and Cardiovascular Surgery of 1986, said it's going to ruin cardiac surgery. Well, we all know that wasn't the truth. truth. In fact, these particular publications, which made transparent information available, changed how we provide health care. And then finally, the ugly. Anybody here, one of the 2 billion Facebook users? Check your data security. We know that what occurred at Cambridge Analytics in 2016, 87 million subscribers to Facebook had their personal data shared and exploited. So, and we know if anybody, unfortunately, has invested in the tech sector over the month of March, you've seen your portfolio decline quite significantly, and these companies have all lost literally tens of billions of dollars, not only for this reason, but other reasons that are occurring as well. What is data? I mean, we talk about it like it's an issue that we all understand completely, and we really don't. We're going to hear Dr. Tesdale in a few hours talk about a better indication of how data is used. But if you looked at the textbook definition, it's just an observation of a parameter at a certain point of time. You know, what happened when? Knowledge is what we do if we look at that data, interpret and analyze it correctly, and then finally information is what we've got after we've done that. Everybody attending these sessions, whether it was yesterday or this morning or tomorrow, you will learn new information that then you'll incorporate and decide whether or not is beneficial to improve your overall practice. But what is data effectiveness? It was published by this brief editorial, and it said it's got to be non-ambiguous. You got to know exactly what it is you're measuring. It must be available in digital form. You know, handwritten documents are not effective, and it must be longitudinal and outcome-based. It must go over the continuum of care. We know in the United States that we look at 30-day readmission values to determine the efficacy of pay for performance and value-based delivery of health care. Now it's supposedly going to go to 90 days. Those are things that we didn't do 20 years ago. So let's talk about something, again, one last historical fact before we get into some more perfusion information. And this was information written by Newton back in the 17th century. And this is called the inductive method of discovery. And so what he said is we take this information from observations, we translate it into some form of data, you analyze the data, and then, of course, you're using that to generate new knowledge, which in the healthcare environment, of course, is improving patient care. So that's kind of a brief summary of what's going on. Oh, if you look in the Bible also mentions data in 2 locations as well. And they're specifically, both in Psalms and Proverbs, are referring to it as developing knowledge. So anybody in the room today, and I know that we have some students, you know, we're always asked, you know, what do I need to do to prepare for entry into the field? How can I make myself more valuable? We always have the same thing that we tell individuals. It's become a data manager. Understand analytics, those statistics courses that we all took many years ago, they actually are valid and have a strong place in regards to how we can position ourselves for employment. So why measure? You know, and some of these that are up here on the screen are known to all of us. We want to reduce unwanted variation. That's a strong aspect of what we know the feds have done in regards to value-based purchasing and reimbursement. We know that 6% of hospitals' Medicare dollars are withheld until they reach a specific minimal value of performance due to usually Press-Ganey type of information. We answer questions and transparency. This is in Piccadilly Circus, I believe, is the location of that. How'd you like to go into that bathroom and kind of be weird to sit or stand there, I guess, and to use this? But I found this, and it reminded me of an event that occurred to me about quite a while ago. We were purchasing. I was the manager of 3 hospital systems, and we had, I don't remember, 9 heart-lung machines. We were buying a commercially available integrated medical record for those devices. And there were quite a few. They were very expensive. This is 20 years ago or so. And I remember sitting with the chief of cardiac surgery who was overseeing all 3 of those. And he basically threatened me. He said, you make sure that we don't become more vulnerable with that information if it gets out into the general public about what we're doing by electronic recording. And I thought that was really strange, It's like, oh my gosh, he's afraid that by using electronic data, we're actually going to make it worse or make us more vulnerable from a medical legal perspective. It was actually the opposite. If you look on it, if you have electronic data, it protects you more than if you have a hand record, and we'll go over that in a second. And finally, what is data? Well, without data, you're just another person with an opinion. And if you look at the evidence, how we rank evidence today, opinion-related research definitions are what's called a 3C recommendation, which means you should not follow them at all. So just when you get all your gray hair and you think people are going to pay attention to you, we're rated at the very lowest of the scale. So, but that's all it is an opinion. All data is not created equally. This Dilbert cartoon, I think, says it well. Just because we have data or measured or doing some analytical structures, we know there's problems that could be associated with not only the quality of the data, but how we go through our analysis. Tom Hankins, just out the road here at the University of Florida in Gainesville, in 1980 presented this at the proceedings at an AMSAC conference, was the first one ever to talk about using computers in the assistance of cardiopulmonary bypass. He looked at 70 patients. These were patients put on bypass, and all he did was he managed a group of them. I think it was actually evenly split, 35 with computer parameters and 35 without. And he showed that with the computer, he was able to meet the requirements that he could without the computer. This is his figure 6, and this was a floppy. Anybody here remember 5 1/4 floppies? I mean, and these were devices. In fact, back at that time in 1980, there were no such thing as hard drives. You loaded your software into one of your drives. He had 2 drives shown on the previous computer, and then you put your data disk in the other. My first purchase of a computer was in 1984, 85. I bought a Macintosh computer just when they came out, and I was absolutely that way. You had 2 floppy drives in it. You put, these were 3.5-inch disks. Apple was a little bit further ahead. You put your Microsoft Word in the top and then your data disk in the bottom. There was no hard drives back at that time. Jeff, I mentioned Jeff, why Ty was smart enough to invite him to present. Well, Jeff clearly has a long history with computer assistance. In fact, this was Jeff's first foray. This is a computer type that he used. It was a TRS-80 microcomputing system. Later became known as just a TRS-80 model, I guess. I don't know if that's less or more. But it came out in 1977, and when they were first released, and actually in the early 80s, they sold for $600 for the entire setup that you could purchase. When I bought my Mac in '84, I paid $2,500 for it. So if you wanted to use Apple when they first came out with it, you surely were spending a lot more money than on the PCs. Jeff measured some great things. You know, he's got a great mind. He could think about these things that many of us cannot. And he said, let's just go ahead and measure these basic parameters. And what he came out with was this in his summary. If we quantify and document what is being monitored and we are able to retrieve it, then we'll be able to develop a more quantitative approach to patient management. Hence what we're doing today when we do variation reduction across all of our medical systems. This is the last paper I have for Jeff, and a few years later, that was in 1981, he published that. In '85, he published this, and he said, you know what, we can hook up a computer to a heart-lung machine via COM ports, collect data, and then perfusionists can use this information to go ahead and to change how they're practicing perfusion by doing quantitative analysis on the outcomes. So Jeff, you know, clearly was portending about what we would be doing, and most of us, of course, are doing that today. So let's now shift to the Perfusion Electronic Medical Record, or PEMRs, whatever they happen to be called, and it comes down to really paper or plastic. And it's about, the best estimates that are out there, about 70% of our hospitals, over 1,000 in the United States, use paper, and 30% are using some electronic medical record. Well, why? Why shift to EMRs? And just a couple of papers here to report. This is by Tanzer and Associates, and they just looked at oxygen saturation in individuals in the ICU. You know, oxygen saturation, you know, basically putting on a pulse ox is so critical. In fact, if you look back in the history of medical malpractice, prior to the standardization and the absolute determination that pulse oxes should be put on just about every patient in a hospital, 1A recommendation, the amount of legal claims against institutions was extremely high. Once pulse oxes were used, they dropped tremendously. But what he had shown was, okay, if you take a small little study, 16 patients, and you automatically collect the data as opposed to manually collecting the data. This is what a nurse was doing at the bedside, writing down the numbers. This was the automatic. These are median values over some large number. And you look at the difference, you can see that the manual recording data is 6.5 percentage points higher with saturation. So that's real problematic. Anybody want to relate that to perfusion parameters? That says your SVO2, what you're manually writing down, you're writing down at 80, but it really is 71. Or 72, or some, whatever the difference would be. And they stated that by doing that manual recording, it does not reflect physiology. These were sick patients in an ICU. compared with automatic sampling, and although they didn't measure outcomes, they said that this can be really bad. Jane Ottens and the group from Madeline Australia, they were leading the way of this in the mid-2000s. And what Jane and Rob Baker and others, Richard Newland, stated was, let's just measure. They had two perfusionists sitting there, one with a handwritten record, and one who was just looking at the Connect EMS system from the Sorin at that particular time. And they measured them. So here's the manual recording, and this happens to be minimal arterial pressure. This is arterial pressure, and this is maximum, and this is manual, this is electronic. And so this is what we're writing down. This is no surprise to anybody in the room. If I ask you to write down, you have parameters 50 to 80 for your pressure, what percentage of time do you think you're going to be in 50 to 80? It's going to be very high. But what the electronic data was showing us was that it wasn't true, and that was also true at the maximum pressure. So here we're saying we're not actually above 80 millimeters of mercury, but we really were, and that was true in a number of parameters, and this is just arterial blood temperature showing the variation that is occurring here. Anybody remember the 2015 publications that came out, first time in the history of perfusion, cardiac surgery, and anesthesia? The same paper was published 3 times simultaneously in an anesthesia journal, the Red Journal of Cardiothoracic and Vascular Anesthesia, the Annals of Thoracic Surgery, and JECT published the same paper. That's called duplicate publication and plagiarism unless you get permission to do that. And the reason they did that is they said the standards and guidelines by surgeons, anesthesiologists, and perfusionists are don't let your arterial blood temperature hit 37 degrees. 1C recommendation. That means you have to do it. If you get caught not doing it, you will be held liable. There's no defense for that in any medical legal court in the United States. It's published in all 3. So once they come out with those strong guidelines at the 1C level, you have to think very carefully about the cardiac team for not following them accordingly. So what is a summarization on why we integrate informatics in clinical practice? We get better accuracy, quality monitoring and improvement we'll talk about, performance reporting, benchmarking, and others that are on this list. And secondarily, we can transfer the information into registries. We can go ahead and statistically analyze this carefully, and then, of course, use it in research. What's available on the market today? We have a great session that's going to be at the end at 5 o'clock next door, I believe, and this is on the devices that are currently out there. Most of these manufacturers are here. And most of them have had electronic health records for quite a few years. Talus is the most recent one that's entered into the market and has a very sophisticated integrated system, as the others do as well. And we know that some of the companies continue to invest quite a bit of money in research and development in the field of EHR, and some of them have backed off because the market isn't as strong. So why do it? The benefits, automaticity, transferring the data, centralized data management, customizable reports, all of these, which anybody in the room who's using them are well aware of. Unfortunately, they're complex, they're expensive. In fact, when we first integrated those 9 systems at our particular hospital, one of our perfusionists had a dedicated phone line that he had, Jim Pizzuto, a phenomenally bright guy, and he was our data manager. He just spoke with Germany, where we just happened to use the Sorin, because of all the problems associated with getting the system to work. It is not a plug and play, and none of these are today. They do take some work, and of course they are expensive. So one of the reasons that we do the integrated automatic data systems is they accurately capture the information, HL7 compliant, data integrity, cloud-based storage, alert notifications. These are the mandates, and if you read any of the product literature they have, they describe that. That's not saying that the 2 other systems that are out there, Brian has developed a really nice system on cloud. You've been seeing it throughout this meeting. And he is also HL7 compliant and working on issues of integration. But these are more user-friendly types. And Steve Peterson at the top in PDS Medical Solutions has done something similar. Steve has been doing this for 20 years now. These are great systems and something that's easily achievable because they're tablet-based or computer-based and can be easily mounted on the heart and lung machine. And the benefits are they're user-friendly, malleable. Challenges right now, and I know Brian's probably shaking his head behind me if he's not getting ready to throw something at me. Data management is one of the issues that I know they're working on, and that means what do you do when you have this large amount of data? The other systems have sophisticated transfer mechanisms. These do too, but it's just something that I think is for future development. And I'd love Brian to talk about that at the end. There's a whole bunch of mon-pas out there. In fact, these are the ones that I have access to because I designed one. It's simplistic, based just on Excel, easy to use. And a lot of people are using these right now until you can afford to buy one of these other systems. This just shows a data record. These are alerts. There's no audible values here. But in regards to just using a D.02 delivery with trying to optimize perfusion to a certain value, you can see that these will alert you if you're outside of that, at least visually. One thing to keep in mind, and this is something that's never spoken about in all the papers that are published on goal-directed perfusion, you look at what the patient has before bypass, which is the highest hematocrit that they have, hemoglobin, and then after, it's like we focus in on here as being, oh man, for area under the curve for 5 minutes, I had a D.02 less than 270. Well, forget about that. That patient had been living at an area under the curve at a D.02 for perhaps years. So why for 30 minutes it's going to have an outcome is questionable, although it's been shown. The Adelaide group, Rich Newland, really the smart person of, they're all very intelligent, but Rich is strange. He's a perfusionist, really a statistician in a perfusionist body. And they started publishing in the mid-2000s the electronic capture of data, and that it's going to facilitate quality improvement, quality indicators can be established, and performance records generated. We did something similar. We took data, Jim Pizzuto and myself, we measured 236 parameters, 40 of those were modifiable by perfusionists, and then 27 of them we analyzed very carefully. These are just the parameters, the ranges we set using best available evidence, and this is just an aggregate report that we had, but more importantly, when we started comparing 8 perfusionists that were working with us, we saw this variation occurring. Perfusionist B, for example, had mean arterial pressures that were significantly greater, time period less than 50 millimeters of mercury, and also had highest perfusion temperatures for all individuals. So if you're a clinical data manager and you see this, that would be your low-hanging fruit to involve with that individual with some sort of assistance to improve their performance. Tom Steffens, Jim Rieger published these articles, Inject a few years ago, one actually just last year, about what to do with the EHR to get it into the healthcare system, what to do with the perfusion data to get it in the EHR, which of course is Epic. One used the Viper and one used T-Link. And this is kind of cool, you know, you get it in, instead of just getting your PDF and sending it over, actual data is getting uploaded in the fields of the EHR. I'm not a big fan of this, and the reason being is once it's in Epic, anybody here ever try to get massive quantities of information other than individual patients out of Epic or Cerner? It's hard. It is very hard to do that, to do any type of statistical analysis. While if you take the data from like an on-cloud system or PDS or others, you can then go ahead and do very simplistic descriptive statistics to get that, aha, I got to look a little bit deeper at this particular parameter, whatever it is. So even though they're doing this, you know, I don't know if it's actually really of great benefit other than to say you've got data in the HR. I'm probably wrong, but performance reports, these are things that are generated, and these, I'm sure most of the people in the room here, if you're the data manager in your cardiac surgical department, you're doing this. You're going ahead and you're making these reports. We at Specialty Care, we do this automatically. We have to, 240 hospitals that we're in, and almost 500 perfusionists, so it's something that you've got to do and standardize, otherwise you have a lot of variation, and these reports get sent on the 11th of every month. Every hospital gets one of these reports. We also do individual performance analysis. So this is a hospital, and this is a made-up one. I changed the name, but this is real data. And so we have these indicators. Tier 1 are something that perfusionists are in direct control of. You don't want to analyze a perfusionist perhaps on, I don't know, transfusions, because you could do your best job in the world and then somebody else comes and hangs a unit of blood. You don't want to be stated that that was your concern unless you caused hemodilution, I guess. But we have these different Tier 1 and Tier 2 levels. We can also do very adequate benchmarking. We can do this by the surgeon, the procedure, or by any of the indicators that you happen to be measuring. And obviously, there's hundreds that are being performed. So it's very easy to pull up graphs. when you have this type of information. Here's just first hematocrit on bypass for a particular hospital that's not identified. And this just shows, most people believe, if you look in the literature, that anything less than 25 is a first hematocrit on bypass in routine individuals undergoing cabbage surgery is not good. And so 25 usually is a good cutoff point to start at. And so we can assess where we are over a 12-month period by case count. This looks like about 20 cases per month. And then you could benchmark it. Either benchmark it to, this happens to be, I believe, the best performing hospitals versus the individual hospital. Green is best. So if you're using this to say, look, our best hospitals are able to maintain a 30% hematocrit for all comers on bypass for coronaries, how did you compare to that? So you can set your standards anyway. You could look by quartile analysis. This is just how to use the data. This is not rocket science. This is just saying, all right, let's separate individuals, the hospitals, by 25% performance. And you can't read this, but there's a number of parameters up here that were determined to be interesting to hospitals. Some of the other information that is out there in regards to registry. Okay, you have this data. Now, what do we do? These are the registries that are out there right now, which are cardiac surgery based. There's over 200 in the United States right now, registries, in fact, throughout the world. VA is the oldest, Northern New England right behind them, STS in 1989. This is the biggest. This is what we do most of our risk stratification on. And then you've got Perfusion Down Under collaboration. You have Perform out of Michigan. And then you've got the registry out of specialty care that is now in its 7th year. And then whether or not you're mandated to join it or voluntary participation. But the beauty of it is if you take that information, Theron Pugh, a brilliant perfusionist, Tim Dickinson, really, really bright, a lot of smart people on this, and then go ahead and say, you know what, let's validate the perfusion registry to see how good the data is. You can see down here in the results, the highest success rate for registries is found when electronic medical data is captured, more so than just manually loading the data. Of course, we said earlier, generating new knowledge, a lot of publications, these relatively recent, 2015 and 16, these 2016 and 17. SCOPE is the Specialty Care Operative Procedural Registry that we have, and so a lot of good data coming out from all of these organizations. To conclude, it's been 38 years since the first report of using data for cardiopulmonary bypass to improve the conduct of it has occurred. It's been more rapidly accepted in Europe, and it's starting to receive more utilization in this country. The use of integrated and computer-assisted data management systems, as I had demonstrated, and I apologize if I left any off that some of you may be using, are effective, and they are expanding. These are not going away. There are markets for these. In fact, one company has just signed a contract with expanding their utilization of their device into 100 additional hospitals. And then finally, the data captured, analyzed, and summarized will transform the delivery of care and ultimately improve outcomes. So I leave you with 2 quotes. I think everybody knows Deming, who was really an engineer, statistician, professor, the father of really mathematical use of reducing variation in various industries. And he said, it's not enough to do your best. You must know that what you're doing is the correct thing and then do your best. So that's probably pretty profound. But he also said this, "In God we trust, all others bring data." And I think that's important because in order to get our points across, we surely have to be using something more effective than just telling them that we know what we're doing because we've been doing it a long time. So with that, I thank you very much for your attention and the ability to set the stage for several of the other presentations that will occur. Thank you.